Good morning, students. Our topic is logarithm. We are going to discuss about logarithmic functions. Okay, I'll take example. It is 3 power 4 is equal to 81. Okay, so this 4 is called the exponent. Okay, so if you multiply 3 4 times, you will get the answer as 81. Okay, 3 power minus 4, that can be written as 1 by 3 power 4, that is equal to 1 by 81. You see the power, here it is positive, here it is negative, so it may be fraction also. Okay, so the exponent, the power, it's a real number that it takes value in as minus infinity to plus infinity. Okay, you look at the answer. Here you are getting 81. Here it is 1 by 81. Okay, so this value is always positive. Okay, it will not be negative. So the exponent may be positive, negative or fraction, whatever it may be. But here 3 power 4 is 81 and 3 power minus 4 is 1 by 81. So the answer is always positive. Okay, so see now, this term can be written as log of, both are equivalent, log of 81 to the base 3 is equal to 4. Log of 81 to the base 3 is equal to 4. If you have 3 power 4 is equal to 81, that can be written as log 81 to the base 3 is equal to 4. So here we have said this answer is always positive. So here this answer is written beside of log. So log of any value or any function x or y, that value is always positive. Okay, so here the answer log of that function or log of that value is maybe positive or negative. Okay, got it clear? This is the very important result. You see that I explained with the particular example. Now I am going to take the general function y is equal to a power x. This a, the base a, is not equal to 1. So if it is equal to 1, 1 to the power anything is 1. So the answer is 1. So that's why this a should not be equal to 1 and a greater than 0. Here the base we always take it as a positive 1. So y is equal to a power x. This is equivalent to, this can be written as log y to the base a is equal to x. Okay, so see now, this function is called the exponential function. Okay, this is called the exponential function. You can see that domain of exponential function. What is domain? It's a first element set. So what are the where the function lies? Okay, so that is x value. What is it? The power may be, what I have said, it may be positive or negative or fraction. So therefore the domain of the exponential function is minus infinity to plus infinity. And the range of this exponential function, that is the y value. So y value, how it should be? It is always positive. So the range of the exponential function is 0 to infinity. Okay, so this log y to the base a is equal to x is called the logarithmic function. Okay, so see now, here we are using the y, that is the x value of logarithmic function, isn't it? Okay, how is your y? What is y? It is a power x. This a power x is always positive. So therefore the domain of logarithmic function is 0 to infinity. Logarithmic function is defined only for positive real numbers. The log க்கு பக்கத்துல இருக்கிற value negative-ல எழுத மாட்டோம். So logarithmic function is defined only for the positive real number. Okay, so log y to the base a is equal to x. how the x should be. X எப்படி இருக்கலாம், பாசிட்டிவாக இருக்கலாம், நெகட்டிவாக இருக்கலாம், ஃப்ராக்ஷனில் இருக்கலாம். ஸோ therefore the range of logarithmic function is -infinity to +infinity. ஓகே, அப்போ எக்ஸ்பனென்ஷியல் ஃபங்க்ஷனோட டொமைனு லாகர்தமிக் ஃபங்க்ஷனோட ரேஞ்ச் ஆகிடுச்சு. எக்ஸ்பனென்ஷியல் ஃபங்க்ஷனோட ரேஞ்சு லாகர்தமிக் ஃபங்க்ஷனோட டொமைனாக இருக்கிறதுனால the exponential function and logarithmic functions are inverse functions. They are inverse function. Okay, so this is the very important result. Okay, we know that a power 0, anything to the power 0 is 1. So how it can be written as using log 1 to the base a is equal to 0. But what is the value of log 1? It is 0 for any base a. What is, we have found one answer, log 1 is equal to 0 for any base a. Okay, so we'll get this. Okay, so see now the properties of logarithm. The first property, because these are very important rule, and this rule only we are going to do it in the problem. We are going to solve the problem. So you have to understand the properties of logarithm. Okay, you look at the first property, a power log x to the base a. Okay, base should be in the suffix. Okay, a power log x to the base a. Keep in your mind the exponential function oda base the logarithmic function oda base if they are equal, so the answer is x. A to the power log x to the base a. So the exponential function oda base enna a. What is the base of logarithmic function? That also a. So your answer is x for all x belongs to 0 to infinity. In a log ku pakkathula vara number illa function, how it should be? It should be positive real number. Okay, so see now, log a power y to the base a. This is your a base. Log a power y to the base a. So the log oda base enna a. So a power y is an exponential function. Adoda base enna a. Here also how they are? The log base exponential function oda base same ah irukradanaala the answer is y. Okay, so y enga irukku? Exponential function, the power la irukku. Okay, and the power எப்படி இருக்கலாம்? All the real numbers it can take. எது மட்டும் தான் பாசிட்டிவ் ரியல் நம்பரா இருக்கணும்? லாகுக்கு பக்கத்துல வரக்குற நம்பர் இல்ல log of any function, it takes only the real number. Okay, come to the product rule. You may study it in 9th and 10th standard. Okay, for any x comma y greater than 0, log of xy to the base a can be written as log x to the base a plus log y to the base a. Here the base is used as a, so we have written log x plus log y. Okay, see here the functions, they are in the product. In the same way you will have the quotient rule, log of x by y to the base a. If they are in division, they are in the quotient. In logarithmic, how it will change? Log x minus log y to the base a. So next you are moving to the power rule. See, log a x power r. You see the first, what's the difference between these two? Here what I have said, logarithmic function oda base exponential function oda base same arna, the answer is y. I have said, you see that what is the base of logarithmic function? It is a. What is the base of exponential function? It is x. They are different. Okay, upper log x power r to the base a. If we have like that, so the power r will come to the front. That is r into log x to the base a. That is called the power rule. The next one, we are moving to the change of base. If you want to change the base of the function, logarithmic function, what you have to follow? For any x greater than 0, I have said log ku pakkathula irukra function, it should be a positive real number. So that's why we have mentioned x is greater than 0 with a and b as bases. A b bases. If log x to the base b. If we want to change the base b to a, b a மாத்தணும்னா எப்படி எழுதணும்னா, first log x to the base a divided by log b to the base a. Okay, base what we want to change? B ன்னு இருக்கிறத a ன்னு மாற்றணும். அப்போ இந்த numerator as well as the denominatorல base what we have written it is a. The numerator இங்கே என்ன ஃபங்க்ஷன் இருக்கோ அதை எழுதணும். log x to the base a divided by log b to the base a. So you see that. So this result only we are going to use it in the problem. Log x to the base 2 is here. Okay. If you want to change the base as x, இப்போ இங்கே 2ன்னு இருக்க பேஸு நீங்கள் இங்கே இருக்கிற இந்த ஃபங்க்ஷனை பேஸாக மாற்றணும் அப்படின்னு சொன்னால் how will you do? So what is your base now? X. அப்போ log இங்கே what the function here you are having you have to write log x. What's the base you want to change? X. So log x to the base x divided by log 2 to the base x. Okay, see now the change of base formula. You see now here base is b, you want to convert to the base, you want to change the base as a, வேற ஒரு base மாற்ற போகிறீங்க. அப்போ how it will be? Log what here you are having you have to write log x to the base a divided by log b to the base a. Okay, இப்போ now in this result you are going to change x as base. So இங்கே அப்படியே interchange பண்ணும். So it's a log function. Here the base is 2. So now you want to change the base as x. About what you have to do? Log what the function here you are having you have to write. So x. What the base you want to change? X. So log x to the base x divided by log the old base 2 divided by the new base x. Okay, so I have said in the first result, you see that log oda base and the exponential function oda base same ah irukkinga. அப்ப இதோட பவர் மேல என்ன இருக்கும்? 1 ன்னு இருக்கும். அப்ப they same ah இருந்தா the answer is 1. So log x to the base x இங்க the நம்பரும் அந்த பேஸும் same ah இருந்தா in logarithmic function the answer is 1. So 1 divided by log 2 to the base x. So if you want to interchange this number has base, so the answer how it will be written? 1 by log 2 to the base x. We can change it. So common logarithm, that is the base is 10, log x to the base 10 is called the common logarithm. Natural logarithm, it can be denoted as the base is e. So e is a irrational number. Okay, appa log x to the base e. Okay, so it is denoted by this log x. In this way also it can denote. Appa here your base is e na artham. Binary logarithm, log x to the base 2. Okay, this is called the binary logarithm which is used in computer science. So using the formula we are going to do the exercise 2.12. You look at the first one. B greater than 0. B is greater than 0 and b is not equal to 1. Okay ma? You see, b is greater than 0 and b is not equal to 1. X plus y is equal to b power x in logarithmic form. So now it is in the exponential form. Y is equal to b power x. Okay, how to write in terms of log? Log, okay, so log y to the base b is equal to x. Okay, log y to the base b is equal to x. So logarithmic function is used to find the exponent. அப்போ இந்த exponent the பவரில் இருக்கிறதா logோட ஆன்சராக வரும். So log y to the base. So exponential function ஓட base வந்து b. So log y to the base b is equal to x. Okay. So I have already said இங்கே what is it? This is the logக்கு பக்கத்தில் இருக்கிற number. And the number how it should be? It is a positive real number. So the domain of logarithmic function is 0 to infinity. And the answer is x. X where it is? It's on the power. The power how it may be? Any real number. So the range of the logarithmic function is minus infinity to plus infinity. Okay. So see the second problem. So what is it? So compute log 27 to the base 9 minus log 9 to to the base 27. The answer you have to find out. Okay. So see now I consider the result. This 27 can be written as 3 power 3. 3 power 3. Here log 9 can be written as 3 squared. So here I am going to apply the power rule. You see the power rule. So what I have said, log x power r to the base a can be written as the power will come in the front. Okay, so see here in the same way. Here what is the power? This power is 3. Okay, the base are not same, so the power is 3. So using power rule it will come in the front. Log 3 to the base 9 minus, in the same way this 2 will come as a front using power rule. So 2 log 3 to the base 27. Okay, you see now I want to change the base as 3 because here you are having log 3, here you are having log 3, but here the base is 9, here the base is 27. So if I want to change the base as 3 means in the 3 base மாறணும். So I have said the remark. Have you remembered? You see now here this number, if you want to change as base, what's answer you have to write? 1 by log 2 to the base x. I have explained here. So the change of base rule. You see now here you are having 3. So already 3 is here. So 3 1 by log 9 to the base 3. Okay, minus 2 is here, it is present. So in the number, if you want to change as base, how it will be written? 1 by log 27 to the base 3. Okay, again this 9 can be written as 3 squared and 27 can be written as 3 cube. You see now here the base and the exponential function base are same. So we can write the answer as 2. So here I have applied the power rule again. Directly also you can come to this step or you can apply the power rule. So the power rule, the 2 will go to the front. So 2 log 3 to the base 3. So what's answer? This is 1. Okay. So direct you can bring it to the step. So it is 3 by 2 minus 2 by 3. So if you take LCM, the LCM is 6. Okay, so 3 3s are 9. 9 minus 4, that is equal to 5 by 6. Come to the third problem. Solve log x to the base 8 plus log x to the base 4 plus log x to the base 2 is equal to 11. So this term is given. You have to solve it. That means you are going to find the value of x. Okay, see now log x is there. The base is different. First term 8, second term 4 and the third term is 2. So I am going to make the base as x in all the terms. So what I have to do? So this number you have to change as base. So it can be written as 1 by log 8 to the base x. So now you change the base, you are going to change the base as x. That means 1 by log 4 to the base x plus 1 by log 2 to the base x is equal to 11. So 8, how it will be written? It is 2 cube and 4 can be written as 2 squared and here there is no change. So 2 cube, how? If you use power rule, this 3 will come in the front. So 3 log 2 to the base x. Again the same power rule if you use, 2 will come front. So 2 log 2 to the base x. Here no change, log 2 to the base x, that is equal to 11. From all the terms what is common? 1 by log 2 to the base x, isn't it? So if you take it out, what is remaining? 1 by 3 plus 1 by 2 plus 1 is equal to 11. So it is in the denominator. So when you take it to the next side, it will go to the numerator. You just take LCM of this term. What is the LCM? 6. So here 2 plus 3 plus 6. So what's answer? It is 11. So this 11 and this 11 getting cancelled. So you bring this term to the denominator. So 11 getting cancelled. Here you are having 1 by 6. So here it is equal to log 2 to the base x. You just bring it to the denominator, and 6 is already in the denominator, so when you take it to the right side, it is 6. Okay, so 1 by log 2 the base x means we can write this as change of power rule if we apply. So it is log x to the base 2, isn't it? Log x to the base 2, that is equal to 6. So logarithmic function it is there. So if you want to change the exponential function, how it will be written? The base 2, the exponent, the power 6, 2 to the power 6 is equal to x. It's a definition of logarithmic function and the exponential function. So 2 to the power 6 is equal to x. So first you have to write the base, then the power, that is 6, is equal to x. What is 2 power 6? That is equal to 64. So x value is equal to 64. Okay, come to the problem number 4. So solve log 2 power 8x to the base 4 is equal to 2 power log 8 to the base 2. Okay, so this is here logarithmic function, here is the exponential function. You see that logarithm base வந்து 4, but exponential base வந்து 2. So what we have to do? We can't do 8x and you should not write. So you can apply the power rule here. So this 8x will come to the front, 8x log 2 to the base 4. Now you look at this, it's a exponential, 2 power something is there. So 2 is the base of the exponential function and the base of logarithmic function is 2. So it will be written as 8. Got it clear? Otherwise this can be written as 8, can be taken as 2 cube. So if you apply the power rule, the 3 will come to the front. Upper 2 power 3 log 2 to the base 2. That is 1 item. Upper 2 power 3 also 8. But here I have used the exponential function base is 2 and the logarithmic function base is also 2. So if they are same, so this will be the answer. So I have written as 8. Okay. So both the sides, the 8 getting cancelled. So x log 2 to the base 4 is equal to 1. So bring this term to the denominator. So x is equal to 1 by log 2 to the base 4. So 1 by, if it is so the base 4, here you are having the base, so it will become the number. So log 4 to the base 2. Okay. So 4 can be written as 2 squared. Okay, again use the power rule, this 2 will come to the front. So 2 log 2 to the base 2. So this answer is 1. So you are getting x is equal to 2. Okay, come to the problem number 5. So if a squared plus b squared is equal to 7ab, show that log of a plus b by 3 is equal to half into log a plus log b. What is the given result? A squared plus b squared is equal to 7ab. You have to show the left hand side is equal to right hand side. So you consider the left hand side. What you are having? Log of a plus b by 3. So that I have taken as y. Okay, so it is a plus b by 3, that this log, when you take it to the next side, it is e power y. Otherwise you can use the definition of logarithmic and exponential function. So here no base is given. Okay, no base is given. So therefore we have to take the base as e. So e to the power, what is it? Y, that is equal to a plus b by 3. Otherwise, logarithmic function and the exponential functions are inverse function. So when you take this logarithmic function to the next side, it will become e power y. Okay, but squaring on both the sides. So when you square, it is a plus b by 3 the whole squared is equal to e power y the whole squared. So when you expand, it is in the form of a plus b the whole square. So a square plus b square plus 2ab divided by, what is 3 square? That is 9 is equal to, how it will be written? E power y into e power y. So the base is e, the power is y. So if the base are same, you have to add the power. So y plus y is 2y. So e power 2y. Otherwise this power has to be multiplied. So e power 2y. Okay. What is given? A squared plus b squared as? It is 7ab. So here 7ab plus 2ab divided by 9 is equal to e power 2y. 7ab plus 2ab is what? 9ab. So 9 getting cancelled. So here you are having ab, that is equal to e power 2y. So you can write as in terms of logarithmic function. So log ab is equal to 2y. I have said already, exponential function and the logarithmic functions are inverse. So log, when you take it to the next side, it is e power y. So here you are having e power 2y. So when you bring it to the left side, it is log ab is equal to 2y. Okay, log ab, what is the formula? It is log a plus log b. It's a product rule. So I have written that is equal to 2y. So when you take it to the left side, it is 1 by 2. So what is y? Y is equal to half into log a plus log b. Here we have taken starting result. What is your y? It is nothing but log of a plus b by 3. So when you substitute in the place of y as log a plus b by 3, so that is equal to 1 by 2 log a plus log b. Okay, so we have proved the result. Come to the problem number 6. It is very simple. Prove log a squared by bc plus log b squared by ca plus log c squared by ab is equal to 0. So we have to prove the left hand side is equal to 0. See, first you consider the first term, log a squared by bc. Okay, so you have to apply the quotient rule. But that can be written as log a squared minus log bc. Okay, so use power rule. So the basis, nothing is given, so we have to take it as e. We need not write. So log a squared. So using the power rule, the 2 will come to the front. So it is 2 log a minus. So here you are going to use the product rule. So log b plus log c. So if you apply the minus to both the terms, it is minus log b minus log c. So first term answer I have found it. The same way, take the second term, use the quotient rule, log b squared minus log ca. So the power rule apply panna, this 2 will come to the front. Here you have to apply the product rule and apply the minus, so you will get the second term. In the same way, you can evaluate the third term. So it is 2 log c minus log a minus log b. Okay, the three terms, what you have to do? You have to add all the three terms. You see the first term of each one. It is 2 log a. Here you are having 2 log b. The third term you are having 2 log c. So I have added the first term of 3 results. Next, you see the next one. Remaining terms all are in minus. You see minus log b, and the third term also you are having, what is it? Minus log b. So minus log b is minus 2 log b. In the same way, you see that log a, see minus log c minus log c. So you are having minus 2 log c. Then minus log a, here also you are having minus log a. So from the remaining terms, minus 2 log a, minus 2 log b, minus 2 log c. So if you add all the things, this is in plus, this is in minus. So everything getting cancelled, the answer is equal to 0. Thank you, students.